All right, we're going to do study guide 23. Problem number 1. We had to decide which expression below is equivalent. So for number 1, we have the expression 2 times 2 to the second power, all to the negative second power. We have to go inside parentheses and simplify that first. There's a 1 there, so we copy the base when we're multiplying powers of the same power. And then I add the 2 exponents. 1 plus 2 is 3. Next thing we do is power of power. When we have it like this, with power next to power, we multiply those two. So this is 2 to the negative 6. Expression 1 has 2 to the negative third times 2 to the third times 2 to the negative 6. Just like we did up here, we're going to copy the base and add all these exponents. If I got opposites, those are going to cancel out. So what I have here is 2 to the negative 6 power. This is the same thing. Expression 1 is the same. Expression 2. Expression 2 has 2 to the second power divided by or over 2 to the 8th power. Copy the base. This is where we subtract the exponents. Top minus bottom. Top minus bottom. That's the same as our original expression. Expression 3. Expression 3 has 2 to the negative 6th times 2 to the negative second divided by 2 to the negative second. So again, first do the product of power there. Copy the base, add the 2 exponents. Now I'm doing quotient of power. I copy the base, I go top, minus, be careful here, you have to put another negative. Okay, if I do the rule for subtraction, add the opposite, I see that those are opposite teams, so I subtract. There are more negatives than positives, so that's the same also. Expression 4. Alright, expression 4, we have 1 over 64. Well, I got to see if this is the same thing. A negative exponent means to flip it. Once you flip it, it's positive. So if I have 6 2's, if I have 2 times 2, 6 times, and I know that 3 2's is 8, this is 8 times 8 is 64. This is the same thing, so all of them are the same. So for that problem here, we should have picked the answer where all 4 are equivalent. Number 2. We're going to find the product of these two scientific notation numbers. So I have 3 times 10 to the 13th power times 2.3 times 10 to the negative 4th power. Okay, I'm going to multiply these two over here. I got 2.3 times 3. 6.9. Now I do my tens. I copy the base and I add the exponent just like I did with those other ones. Okay? Opposite teams means subtract. I have a difference of 9. There are more positives than negatives. There's my answer because my decimal is already in the right spot. Sometimes we have to rewrite that and regroup our tens, but this time we do not because the decimal is already in the right spot. So that was number 2. Number 3 on our study guide. We have 1/5 of 10 times some number plus 40 plus 3 equals 45. What's that number we're trying to figure out? What goes there? So solve this. Okay, let's separate our left from our right side of the equations. If I'm going to distribute a 1/5, that's like dividing these by 5. So that's going to give me 2x plus 40 divided by 5 is 8. So I distribute and combine like terms. That's my mantra when I'm trying to simplify. Distribute and combine like terms. So combine like terms. Now I can solve this equation. I work farthest away from the variable first. And then I divide both sides. Division property of equality. And half of 34 should be 17. So my answer is 17. Alright. Problem number 4. Pick all of the equations that have no solution. Well, if it has no solution, again, we're going to simplify both sides, distribute, combine like terms, and if it's no solution, you're going to have the same coefficients, but different constants. So expression 1. Expression 1, I have negative x plus 2 equals negative, parentheses, x minus 2. Okay? This side's already simplified. Here we have to distribute the negative. Negative times positive is negative. Negative times negative is positive. These are the same thing. That's infinitely many. That's not no solution, so we don't pick that one. Okay? Expression 2. equation 2, sorry. Equation 2. We have 4 times the quantity 10x plus 2 minus 7 equals 15x minus negative 1 plus x. So let's simplify both sides. Okay, I'm going to distribute first. I get 40x plus 8, right? 4 times 10x, 4 times 2. Now those parentheses go away. Over here I have to distribute the negative. So I have 15x plus 1 minus x. Combine like terms. 40x, 8 minus 7 is 1. Over here, I got 15x. I'm going to take away one of those x's. You see I have different coefficients. That's automatically going to have one answer. That's not a special case. Okay? So, don't pick equations 1 or 2 so far. Alright, equation 3. I have 2 minus 12 times 2x. Whoops, I'm sorry. That's equation 4. Equation 3 is negative 5 plus 6x minus 7 equals negative 2x plus 8 times x minus 5. Let's simplify both sides to see how many solutions this will have. Distribute, I don't have to distribute, so I just combine like terms. If I have 5 negatives and 7 more negatives, that's a total of 12 negatives. Over here, if you can distribute, you must do that first. Let's distribute first. 8 times x is 8x. 8 times negative 5 is negative 40. There's no like terms to combine anymore, so this side is simplified, this side is not. If I have 8 x's and I take away 2 of those x's, I have 6 x's left. I see that I have the same coefficients and different constants. That has no solution. So, equation 3 is one of my answers. Let's check equation 4. Equation 4 has 2 minus 12 times 2x minus 2 equals 2x minus 16x plus 17 minus 10x. Whew. So we're going to go here. Again, distribute combine like terms. That's how we simplify. So I'm going to distribute a negative 12. So negative times positive is negative. That's negative 24x, those two. This 2 becomes positive 24. Parentheses go away. Over here, no parentheses, no distributing, just combine like terms. I combine all my x's. If I have 16 negatives and 10 more negatives, that's a total of 26 negatives. And then 2 positives, those are opposite teams, so I subtract. There are more negatives, so that's a difference of negative 24, but they're all x's. So here I have 26 and a negative 24x, a negative 24x and a 17. These are the same. If these are different, that's no solution. If they were the same, that would be infinitely many. So my answer for this are equations 3 and 4 for question number 4. Okay? Question number 5. Which relations has a greater rate of change? So let's look at our equation here. We're going to take 2 points. Here's one point that's on a lattice. Here's another point that's on a lattice. I can see from there it's a negative slope because it's going downhill. I fall 1 and run 2. So I got a slope of negative 1/2. So let's find the slopes for these other ones. This one, they say it's a proportional line. Relation 1. Relation 1 is proportional, and it goes through the point 4, 8. So the shortcut when it's proportional is just put y over x. This has a slope of 2. This is greater than 1/2. Okay? And remember, we're just comparing absolute values. So that's going to be steeper, okay? Because that's a greater absolute value than a fraction. Relation 2. Relation 2. We're going to take 2 points. Any 2 points you want from that table. And we're going to go y minus y to get the slope, or the rate of change, over x minus x. Keep the same order, right? Left minus right, left minus right. 2 over negative 1, a slope of negative 2. That absolute value is more than 1/2. That's going to be steeper. That one works too. Relation 3. Relation 3. It gives us an equation, and in front of and it's in slope-intercept form because the y is isolated. So the slope is whatever's in front of x. The slope is 1/4. 1/4. The absolute value of 1/4 is not greater than 1/2. And if you don't know how to do that, you just go in and out and to see which decimal you get, compared to this one. And this one will be 0.5. It'll be more than 0.25, so that's not steeper. Relation 4 gives us 2 points. So we go y minus y to get the rate of change, over x minus x to get the rate of change. I get -7. That's the slope of 1. 1 is greater than a fraction. And again, we're just looking at absolute value. So the answer was relations 1, 2, and 4 have greater slopes than the graph. Okay? Now let's go to question number 6. We're going to select a statement that correctly describes the system. Excuse me, sorry, the system. Okay, so we have 2 equations here. This is called a system when you have 2 or more. We got to take one of these and isolate one of the variables. That one does not have a coefficient, so I'm going to isolate that y, because I can do that in one step and I'll avoid fractions. So this is the same as this. So now I have 2 equations, this one and this one. I'm going to plug this one into this one, where the y is. So I have 8x minus 2 times, let me start this again on another piece of paper. I'm rewriting the first equation. I have 8x minus 2y equals -2. I'm going to plug the other equation right there. So I have 8x minus 2, and in parentheses, I'm going to put this part, 4x plus 5. 4x plus 5. I'm algebraically intersecting these to see where they graphically intersect. So I'm going to distribute, again, distribute combined like terms, right? That's how we simplify. Negative times positive is negative. Now I combine like terms. My x's cancel out. When my x's cancel out, that's like one of these special cases where they're the same, because when I do the same thing to both sides, they're going to cancel out. So it's a special case. It's either no solution or infinitely many. If they're different numbers, just like these were different numbers, that's no solution. So what's true about this system over here is there is no solution. So the answer would have been B for this one. Okay? Okay, number 7. What am I talking about? Number 7. Okay, so 7, they give us an equation, part of a system. We have 2x plus 3y equals -10. We're going to pick the equation that has infinitely many. So, if it's infinitely many, it's the same equation. So which one of these was multiplied by the same? Everything multiplied by the same number to get the same exact thing. Infinitely many means same line. Okay. So if we look at the first one, you see the y's, they switch the order on you. So you got to do that. You got to be careful. You got to switch the order over here to see. Okay. So y is first. You put the y first. So it looks like we multiplied by -1. Second term multiplied by -1. Third term did not multiply by -1. That's not the same line. It won't have infinitely many solutions. Number 2, multiplied by -1. Did not multiply by -1. You have to do the exact same thing to everything, right? That's the multiplication property of equality. C, multiplied by -2. Multiplied by -2. Also multiplied by -2. This equation will have infinitely many solutions with this one. And D shouldn't work. Let's see why. D, multiplied by -2. Multiplied by +2. That doesn't work. So answer is C for number 7. Number 8. Nolan, his business sells T-shirts. It says $10 each. That means 10x. But you have to pay a one-time membership fee. One-time fee means starting fee. That means y-intercept. When is that the same as Style by Jaden? Jaden has $11 each. No membership fee. So what do? Set them equal to each other. Solve for x. Subtract x's from both sides, because remember, it's already simplified. So that's when we get our variables on one side. Answer is 15. Number 9. We got to write an equation for this. The nice thing about this is it goes in order. When it goes in order, we can actually see the slope if it's linear. So I can see this is going down by 11 every single time. Okay? So my slope is -11x. Remember, put the slope in front of x, right? And if you see 0, if they give you that, that's excellent. Because if x is 0, this has to be your y-intercept. So if it's plus 0, that just means 11x. There's my equation for that line. Number 10. write the equation for this line. You can see it hits right there at 16. So my y-intercept this time is 16. And we got to take 2 points that are on lattices. I'm going to go down. Now that's not a 1, be careful. It looks like 1, but it's actually, look, 2 of them is 8, so that's got to be 4. I go down 4 to the right, that's not a 2, look, that's a 1. So I go down 4 to the right 1 means a slope of negative 4. Slope goes in front of x, y equals, that's in slope-intercept form. My equation is negative 4x plus 16. Now, on the test, they might switch it around on you. That's the same thing. So know how to rewrite that. Number 10 on the study guide. Number 10 on our test is going to look like this Friday. So number 10, number 11. Number 11 is a right triangle. It says it has a length of 28 units and a hypotenuse that is 53 units. So we have 28 and 53. All right, so we got 28 squared plus something else squared equals 53 squared. Okay, so you guys, just for the sake of time, I'm going to cheat here. We're going to go 53 times 53. We got 2809. So we distribute these two, right? We multiply 28 times 28. We go out to the side and do that. Now we got to isolate the variable. Sorry, I'm not writing legibly here. Now we got to isolate the variable. So we subtract this from both sides. And pretty soon we'll be using calculators for the rest of the year. I think on our next test we'll be doing that. Now we got to figure out what times itself equals that. Okay? So if that doesn't work, if it's not a perfect square, then what we would do then, let's see, what did I do here? I feel like I did something wrong here. Let's see. So let me do this again. 53 times 53, 2809, 28 times 28 equals that, 784 minus 2809. So we got 2025. Nope, it's good. So it's 45 times 45. Okay? So we just narrow that down, right? 10 times 10, 100 times 100. Just narrow it down. You're gonna hit it. Okay? All right. So 12. Again, right triangle problem. It says two sides. One is rad 56. Another one's rad 200. Again, the trick to this one is these can both be legs, or one can be a leg and the other can be the hypotenuse. Just make the big one the hypotenuse, okay? Now, square root of a squared number, that just becomes the radicand, the number inside. So 256 happens to be a perfect square. So you guys start multiplying numbers to see what it is. You're going to see it's going to be 16. Over here, I have 56 plus b squared equals 200. I subtract these two. Okay? I get b squared equals 144. The square root of that is, this time we ended up with two perfect squares. Sometimes that's an irrational number. So 16 and 12 are the two possible lengths for the other sides for that right triangle for number 12. Okay? All right. We are on 13 now, I believe. Yep, another right triangle question. They tell us that the base of a ramp is 24 feet. They tell us that the ramp, or the hypotenuse, is 25 feet, and they ask us how high is the ramp. Okay, again, Pythagorean Theorem. A squared plus a leg squared equals a hypotenuse squared. Okay, so we memorized 25 squared, right, in class. We just said that's 625. So we'll go and we'll do 24 times 24 on the test. Okay, isolate the variable. A squared is difference of 49. Take the square root of both sides, and you see that that has to be 7 units long. Okay, that was number 13. Now we're on 14. Find the exact distance between these 2 points. Okay, so here are the points they give us, right? This one and this one. So if I made a right triangle out of this, I need to find that length right there. Okay, I know that this is 1, 2, 3, 4, 5 units long. This is 1, 2, 3, 4, 5, 6 units long. So a squared plus b squared equals c squared. I have another Pythagorean theorem question, and this time they're asking me to find the hypotenuse. So I simplify 5 times 5, 6 times 6. Add these two together, and I'm going to get 61. Take the square root of both sides. If they want exact answer, it's going to be rad 61. Now that's not a perfect square, so you're done. If they want exact answer. Alright, moving right along. Number 15. Okay, 15 says, what's the distance between these 2 points? Similar idea, but this time they don't give us a graph to just count, so we'll use the distance formula. Subtract your x squared plus subtract your y squared, take the square root. Same thing we did down here. A squared plus b squared equals c squared, take the square root in the end, same thing. So I subtract my 2 x's plus subtract my 2 y's and take the square root. So that's a difference of -1. That's a difference of -2. -1 times -1 is 1. -2 times -2 is 4. Square root of 5 is the answer. Okay? And again, they asked for the exact distance, so you can leave it as a oh, okay, so there's an issue. So on the study guide, I said give an exact answer, okay? But then in the answer key, I ended up rounding to the nearest tenth, so, no wait, did I do that? 14? 14, 15. Yeah, I didn't. I'm sorry. I'm reading the wrong direction, excuse me. I said to the nearest tenths. So what you have to do now is you have to take rad 5, and like we did for all first part of the year, you have to estimate that to the nearest tenths. You should get about 2.2. Okay, number 16. We got a right triangle with one leg that's 3 units, and another that's 4.4. Same thing we've been doing for all these. We're going to find the exact hypotenuse, except this time we're going to go a decimal times a decimal. Okay, we're just going to do 4.4 times 4.4. Same idea as we've been doing though. Okay, so once you go off to the side, do 4.4 times 4.4. Oops. We're going to get 19.36. Add these two together. You get your decimal. And then when you take the square root of both sides, because we got c squared, right? We need c. You're going to have your answer. Rad 2836 is going to be the exact answer for that. Number 17. All right, this is the part. These are the parts that are new here. Now we're getting to translations. Okay, so let me zoom in a little bit here. Okay, so we have 2 rectangles here, and we can see that because the orientation didn't change and the size didn't change, we know it's just a slide, a translation. So I can see here from this point to this point, I slid 1, 2, 3, 4, 5, 6 to the right. I slid 6 to the right, and then I go from there 1, 2 down. Okay, 6 to the right and 2 down. So let's read the statements. The square translated 2 units down, followed by 6 to the right. Well, that's the same thing. They just changed the order. So this one's okay. Number 2, the square reflected over the over the y-axis, then translated 6 down. Okay, so let me see if that works. If I reflect over, my orientation is going to change. So no, the orientation didn't change, so it can't be statement 2. Statement 3, the square translated 6 units to the right, followed by 2 down. Well, that's the same thing, right? So what's true, it has to be statements 1 and 3, I believe. Let's check the answer for 17. Yep, answers 1 and 3. Statements 1 and 3. All right, number 15. Okay, so 15, you see this here? It says that EFG was reflected over the x-axis right here, and then translated to the right. Choose a statement that's true. So if it got reflected, it got flipped. So it's going to kind of look kind of like this now, because it's going to get flipped over like this. Okay, so E is down here, F is here, and G is here. And if you're confused about that, just take the coordinates, write them down, and to reflect over the x, remember you change the sign for all the y coordinates, and you'll see exactly where it's supposed to be. So then it slid this way. Okay, so I can see that this side is the same as A, right there. And the question says the length of EF equals side A. Yep. The length of EF is the same as B. Nope. EF equals the length of C. Nope. And none of the sides are equal. That's not true. That's never true unless it's a dilation. So the answer for that one had to be A for 18. 19, again, looks like the orientation didn't change. Orientation, it goes EFG, so it's a slide. It just went down. So it went 6 units to the right. Nope. 9 down. You got to counter and make sure it's 9. Yep. It reflected, did not reflect because orientation didn't change. 19 has to be B. 20. So we have this shape right here. we're going to reflect over the x-axis, which means change the sign for the y, right? And then 4 units to right, add 4 to our x's. So we're only focusing on f double prime. So f is at, if I count this, it's at -3, +7. -3, +7. I'm going to do these two things to -3, +7. If I reflect over the x-axis, I just change the sign for y. So now it is here. -3, -7. From -3, -7, if I go 4 units to the right, that means add 4 to my x's. So this point is now at 1, -7. Okay? And that's how we do this week's study guide.